Welcome back to Summarize Science, where we look at the latest breakthroughs in AI and robotics. Have you ever wondered why robots seem to struggle when they lose sight of an object? Researchers have identified a major problem. Most robots use static maps that can't be easily updated if an initial look was blurry or blocked. To fix this, they developed a system called GSMem, which stands for 3D Gaussian Splatting as persistent spatial memory. This new framework allows an AI agent to build a dense, continuous representation of its environment as it explores. Unlike traditional methods that just store snapshots, this system uses 3D Gaussian splatting to create a persistent memory. One of the most exciting features is something called spatial recollection. This allows the robot to hallucinate or render high-quality images of a room from angles it never actually occupied. The researchers explain that this bridges the gap between simple abstract maps and the actual visual reality of a room. By parameterizing continuous geometry and appearance, the robot can essentially think in 3D. To find specific items, the system uses a multi-level retrieval mechanism shown in their methodology. It looks at both high-level object maps and semantic language fields to locate what it needs. This dual approach is crucial because if the robot fails to recognize a specific object name, it can still find the area based on broader descriptions. The AI can then pick the absolute best viewpoint to reobserve a target for better reasoning, even if it has to imagine that viewpoint. This is far more efficient than traditional robots that have to physically drive back to a location just to check a small detail. They use a scoring system to ensure the imagined view is clear and centered on the object of interest. When the robot is exploring a new home, it uses a hybrid strategy to decide where to go next. It balances the need to find a specific target with the need to fill in the blanks of its 3D map. By calculating where its map is most uncertain, it can prioritize exploring those hidden corners. This ensures that the robot doesn't just wander aimlessly, but builds a complete and useful memory of the entire floor plan. The goal is to achieve balanced and task-aware zero-shot exploration. During testing, this framework was used for embodied question answering, where the robot has to answer questions about its surroundings. The results showed that GSMem significantly outperformed older models that relied on simple 2D snapshots or graphs. Even when object detectors failed to label something correctly, the language-based memory helped the robot succeed. In long-term navigation tasks, the system proved to be incredibly reliable over thousands of different subtasks. They provided case studies where standard maps failed because an object like a white robe was missed during the first pass. GSMem bypassed these perception gaps by using its continuous language field to correctly identify and navigate to the target anyway. To wrap things up, the big takeaway is that robots are getting much better at retaining and visualizing spatial information. This means future robots could navigate complex homes or warehouses with much higher precision than we see today. They won't just follow a path, they will actually understand the 3D space they are moving through. This work moves us closer to AI assistants that can find your lost keys even if they only caught a glimpse of them hours ago. It is a massive step forward for zero-shot embodied exploration and reasoning. Thank you for watching this summary of a truly innovative leap in spatial AI here on Summarize Science.